Hello, and this is organic chemistry. Let's break down the naturally conscious granola bar by looking at one of its main organic components, glucose, a sugar found in the oats and honey. The UPAC name of glucose is 2R, 3S, 4R, 5R. Is pentahydroxy hexanol, but we can just call it glucose in biology and food chemistry. Glucose contains two main functional groups, a hydroxyl group, OH, and an aldehyde group, CHO. These groups make glucose highly reactive in energy-releasing reactions. So in the body, glucose goes through a series of reactions like glycolysis to provide energy. In food science, glucose also participates in a Maillard reaction, which gives baked goods in the golden brown color and flavor. It's originally synthesized in plants via photosynthesis using carbon dioxide, water, and sunlight. That's why it shows up in oats and honey straight from nature. Now let's talk about a carrot. The key organic compound of carrot is carotene, beta-carotene, the pigment that gives carrots their bright orange color. The UPAC name of beta-carotene is BB-carotene, but its full systematic name is long, BB-carotene. UPAC is trans like BB-carotene. Its mainly functional groups are conjugated double bonds, C2C. These alternate double and single bonds allow the molecule to absorb light and appear orange to your eyes. In the body, beta-carotene undergoes a cleavage reaction in the small intestine to form a vitamin A, retinol, which is essential for vision and immune function. Next up is a carbohydrate. The main organic compound in carbohydrate is cellulose, a long-chain polymer made of glucose units. Its UPAC name is poly 1,2,4 PD-glucopyranose, a molecule that is used mainly glucose molecules linked together. The key functional group in cellulose are hydroxyl groups, OH. These groups form a strong hydrogen bonds between chains, giving cardboard its softness and durability. Cellulose is synthesized naturally by plants through polymerization of glucose during cell wall formation. In industry, it's processed from wood pulp to make paper and cardboard. Now let's explore the paper, something we use every day. Like cardboard, paper is primarily made of cellulose, a nature polymer composed of linked glucose units. The UPAC name of the repeating unit in a cellulose is poly 1,2,4 PD-glucopyranose. Cellulose molecules have many hydroxyl groups, OH, which form strong hydrogen bonds that give paper its stretch. Cellulose is synthesized in plants as a part of their cell walls, formed by polymerizing glucose molecules through enzymatic processes. Now in here is something we use every day, and it's essential, a door. Chemically, doors can be made from different materials like wood or metal, and each has its own organic or inorganic chemistry. It's a wooden in a wooden door. The main organic compounds is again cellulose, the polymer made of glucose units linked by B14, B1 to 4, like closide bonds. The cellulose in the wood is strange and rigidity, thanks to its many hydroxyl groups, always forming hydrogen bonds. Wood also contains lignin, a complex polymer with aromatic rings and phenolic functional groups, always attached to benzene rings, which adds stiffness and water resistance. Now we can explore something like delicious, a cake. Chemically, a cake is a mixture of many organic compounds like sugar, fats, and proteins. One important compound is sucrose, common table sugar with a UPAC name BD-fructofuranoxide, and glucopyranoside. Sucrose, common table sugar, contains hydroxyl groups, OH, that make it soluble and sweet. Fats in cakes are mostly triglycerides, which have ester functional groups, COO. This gives cakes their moist texture. During taking chemical reactions in a Maillard reaction occur between sugars and amino acids, producing the golden brown color and complex flavors. Cakes are synthesized by mixing and baking these ingredients, turning raw components into a tasty treat. Next, we have a common office item, a folder. Chemically, folders are usually made from either plastics or cardboard, so let's explore both. If it's cardboard folder, the main component is cellulose, a polymer of glucose units linked by B1 to 4 glycosides bonds. Its many hydroxyl groups OH allow cellulose fibers to bond tightly, giving the folder strength and flexibility. Plastic folders are often made from propylene, a polymer of the monomer propylene. The UPAC name is poly-1-methylethylene. Propylene's structure features repeating units with alkane functional groups CH3 and CH2, make it lightweight and resistant to chemicals. And finally, we have coffee. The key organic compound in coffee is caffeine, a stimulant that keeps many of us alert. The UPAC name of caffeine is 1,3,7-trimethylxanthine. It contains functional groups like amide, CONH, and methyl, CH3 groups, which contribute to its biological activity. The caffeine is synthesized naturally by coffee plants through a complex pathway involving purine alkaloids. In the human body, caffeine blocks adenosine receptors, will reduce tiredness and improve focus. Coffee also contains many other organic compounds, including antioxidants, which have health benefits. So next, let's take a look to a popular food, that is a chicken finger. The chicken finger, the main compounds here come from both proteins and fats in the chicken meat. Proteins are made of amino acids which contain functional groups like amine, NH2, and carboxyl, COOH groups. These groups allow amino acids to link into long chains via peptide bonds. When cooking, proteins undergo denaturation, changing the structure, and a Maillard reaction between amino acids and sugars gives chicken fingers their tasty brown crust. Fats in the chicken finger are mainly triglycerides with ester functional group COOO, which add flavor and moisture.